So here today we will discuss about to solve the initial value problem of the first order by using the Picard's method. So here first we will discuss that how can we proceed to solve any initial value problem by using Picard's method, and then we will solve two problems for finding the solution of any initial value problem of the differential equation of first order by using Picard's method. So let's start. So here, if we consider the differential equation of first order, dy dx is equal to f of xy. And here, this is the first order equation with the initial condition y of x0 is equal to y. So how can we solve this type of equation? So here, we can solve this type of initial value problem that we have to integrate over the line. That is it. From here, we can write that integration over dy is equal to integration over f of x y dx. And what is the limits of dy is y0 to y, and for the x, the limit is x0 to x. So now if we want to solve this one, so we will get that is y of x minus y0 is equal to x0 to x f of xy dx. And from here we can also write y of x is equal to y0 plus x0 to x f of xy dx. So now see here, this is the function of x and y both. So here we can't directly integrate this one. So how can we find that? We have to express y in terms of x, and we will get the next solution by using the successive method. So here, if we find that y1x, the next approximation, we will get that is y1x is equal to y0 plus integration over x0 to x f of xy dx. Basically here we will write f of xy0. Similarly, we will find the y2x as y0 plus x0 to x f of x comma y1 dx. So similarly, as we get that y3x is equal to y0 plus x0 to x f of x comma y2 dx, and here always we get y2 y1 y2 in terms of x. And now we can say that and if we proceeding like this, we will get y n is equal to y0 plus integration over x0 to x f of x comma y n minus 1 x dx. So this is the working formula for the Picard's method. So here by putting n is equal to 1, 2, we will get the approximation and we will get the solution at a particular point. Like if we want to find the the problem is given dy dx is equal to f of xy minus y of x0 is equal to y0. So here we will get also at a point alpha, where alpha is greater than x0, we can find by using this approximation. And here we will get, and this like y1, y2, y3 and so on. So now this is the working formula. Yn is equal to y0 plus x0 to x f of x y minus 1 x dx. Also you can find the another working formula for the Picard's method, that is yn plus 1 is equal to y0 plus integration over x0 to x f of x comma y and x dx. So here both the this is also another working formula. So basically here we will use this working formula to find the approximations on the any initial value problem. So let us choose some problems. Two problems here we will choose, and let us discuss about it how to solve it. So here we will choose the problem that dy dx. Here the question is that find using the Picard methods of approximation. The question is using Picard method of approximation. Picard's method of approximation. Find the third approximation. The third approximation or the solution of the equation. The solution of the equation dy dx is equal to x plus y square, whereas y of 0 is equal to 0. So this is the, we have to solve this differential equation or this initial value problem by using Picard's method. So let us discuss that how to solve this. See here, the given the solution, then how can we find the solution? That is, it is already given that dy dx is equal to x plus y square. Okay, y of 0 is equal to 0. That means x0 is equal to 0 and y0 is equal to 0. F of xy is x plus y square. F of xy is equal to x plus y square. Since the Picard method is a iterative method, so we can write, so here I write the Picard's formula. The Picard's formula is yn is equal to y0 plus x0 to x f of x comma y n minus 1 x dx. So here f of x comma y n minus 1 is equal to, we can write that this is x plus y n minus 1 square. So now in this Picard formula, if we put n is equal to 0, so here I go to the new side. So again I write here the formula yn is equal to y0 plus x0 to x f of x comma y n minus 1x dx. So see here that f of xy is x plus y square, and so as an iterative x y minus n, so we can write, and here if we put in this equation n is equal to 0, then f of x, sorry, if we put n is equal to 1, we get here f of x comma y0 is equal to x plus y0 square. What is the value of y0? And again, it is given that the y of 0 is equal to 0. That means x is equal to 0, y is equal to 0. So we get here that y0 is 0 and x0 is 0. So here we get f x y0 is x. So now from this equation, from the Picard's approximation formula, we will get y1, y0 is 0 plus x0 is 0 to x, f of xy0 is x dx. So we will get this one is half x. Y1 we get half x. Similarly, y2. Y2 means here we will put n is equal to 2 into the Picard approximation. So here we get f of x comma y, that is x plus y1 square. So what is y1 square? That is x plus 1 by 4 x to the power 4, as we get y1 is equal to half x square, as y1 is equal to half x square. So now here we will get f of, so here y2, we get y2 is equal to y0 plus 0 to x f of x comma y1 dx. Y0 is 0 plus 0 to x, x0 is 0 already put here, and this will be f of x y1 x plus half x to the power 4 dx. And if you want to solve this one, you will get x squared by 2 plus, oh sorry, this one is 1 by 4 plus 1 by 20 x to the power 5. So this is the value of y2. And in the given question, we have to find the third approximation. That is, we have to go up to the y3. So y3 means here we will get y3 is equal to y0 plus x0 to 0 f of x comma y2 dx. So here f of x comma y2 means f of x comma y2 means that will be x plus y2 square. So here we will get, this is x plus, what we get the value of y2? That is half x square plus 1 by 20 x to the power 5 whole square. So now if you want to find the solution, y0 is 0, x0 0, 0 to x, this will be x plus half x square plus 1 by 20 x to the power 5 all square dx. X plus, this will be 1 by 4 x to the power 4. Because here we will just uh, elaborate it as a plus b whole square. So we will get 1 by 20 x to the power 7 plus 1 by 400 x to the power 10 dx. So now we have to just simplify this one. We get x squared by 2 plus 1 by 20 x to the power 5 plus 1 by 160 x to the power 8 plus 1 by 4400 x to the power 11. So this is the third approximation of the given equation. So again, as it is described into the question, that find using Picard's method, find the third approximation. So we have to stop here, and this is the y3 you get. Previously you get here the y2 here and the y1 here. So finally write the answer. You just jot down all the values of the approximations, like the y1, y2 and y3. Like y1 you get here half x square, y2 is half x square plus 1 by 20 x to the power 5, and y3 you get here this one. You have to just write this one, that is x square by 2 plus 1 by 20 x to the power 5 plus 1 by 60 x to the power 8 plus 1 by 4400 x to the power 11. So hopefully this is clear to you, that how can you solve this one. Similarly now, I will take another equation, another problem, that the question is here, that solve the following IVP, solve the following IVP, dy dx is equal to 1 plus x, right? where it is given that y of 0 is equal to 1. And also check solve this one by solve the following IDP. This one by using Picard's method, and approximate the value, approximate y of 0.1 and y of 0.2. So we have to solve this one. So dy dx is equal to 1 plus x. We have to solve it by using the Picard's method with the initial condition y of 0 is equal to 1. So see here that here f of xy is 1 plus x. Okay. Y of 0 is equal to 1. This implies that x0 is 0, y0 is 1. So now here we can apply the Picard's method, or the Picard's approximation is y is equal to y0 plus x0 to x f of x comma y and minus 1 dx. So here f of x comma y and minus 1, that means here we can write that f of x comma y and minus 1 is 1 plus xy and minus 1. So here in the Picard's method, I also have to approximate here y of 0.1 and y of 0.2. So whenever we have to find approximations of some value, we will always take at least 3. Up to the third approximation. So here, what is the value of y0? So here, if we put n is equal to 1, so what we get? That is y1 is equal to y0. And what is the value of x0? That is 0 to x. And f of x comma y0, we get 1 plus x y0. Y0 is 1, so it is 1 plus x. So we will get here, that is y0 is equal to 1 plus x dx. The value of y0 is 1, so 1 plus 0 to x, 1 plus x dx. So from here we get y1 plus x squared by 2. This is the value of y1. Clear? Similarly now, we have to find y2 and y3. So see here what you get, y1 1 plus x squared by 2. So similarly now, if we use here again, so again I write here the formula yn is equal to y0 plus x0 to x f of x y minus 1 dx. So here if we put n is equal to 2, so y is equal to y0 plus x0 to x. So f of x comma y and minus 1, that is 1 plus xy n minus 1. Here we put n is equal to 2, we will get 1 plus x y1, and already we gave the value of y1 is 1 plus x squared by 2. 1 plus x squared by 2. So here the value of y0 is 1 plus the value of x0 is 0 to x. So we get 1 plus x squared plus x cubed by 2. From here we get this. And so now if we want to simplify, we will get 1 plus x squared by 2 plus x cubed by 3 plus x to the power 4 by 8. Okay, so we get the value of y2 here. Similarly, now we have to find the value of y3. So again, I also go to another slide. So here y3, same process here. Y3 is equal to f of y3 is equal to y0 plus x0 to x f of x comma y2 dx. So here f of x comma y2 means 1 plus xy2. So here this will be a little bit bigger. This will be 1 plus x into, as we get y2 is equal to this term. So here 1 plus x into, or we will get here 1 plus x. I just write it at a time. X plus x square plus x cubed by 2 plus 1 third x to the power 4 plus 1 by 8 x to the power 5. So here we will get this one is 1 plus x0 to 0 to x. This will be 1 plus x square plus x cubed by 2 plus 1 third x to the power 4 plus 1 by x to the power 5 dx. Plus x to the power 4 by 8 plus x to the power 5 by 15 plus x to the power 6 by 3. So this is y2 and this is y1 already we get. So now here we have to approximate the value and the x is equal to 0.1 and x is equal to 0.2. So here we have to just write the value of y1 by 2 by 3 here. So I just go for the new slide. I hope up to this step the calculation is clear to you. So if there is any problem, you just repeat, pause the video and clear the concept. Okay. Uh, so now here that what we get that y1 is equal to 1 plus x square by 2. y2 is 1 plus x square by 2 plus x cubed by 3 plus x to the power 4 by 8 and y3 is 1 plus x square by 2 plus x cubed by 3 plus x to the power 4 by 8 plus x to the power 5 by 15 plus x to the power 6 by 14. We have to approximate at x is equal to 0.1 and x is equal to 0.2. So here whenever at x is equal to 0.1, you will get that y of 0.1, y1 of 0.1, you will get 1.105, y2 of 0.1, you will get 1.105346, and y3 0.1, you will get 1.105347, and at x is equal to 0.2, you will get y1 of 0.2, 1.22, y2 of 0.2 is 1.2228, and y3 of 0.2, 1.2228. Now see here for both the cases, if you correct up to 4 decimal places, you will get that y of 0.1 is 1.105 approximately, and y of 0.2 is 1.22. So this is the required solution at x is equal to 0.1 and 0.2 is the Picard's Method. So thank you for watching